All right, let's unpack this. It's such a fundamental question, isn't it? Where is the universe actually and what's out there?
Beyond everything we can see, yeah.
Exactly. Is our world just kind of floating in this huge emptiness, or are we, part of something bigger, something with structure?
Those are absolutely the core questions. And um, our source material for this deep dive
Yeah.
really tackles them head on. We're looking at the boundless cosmos,
Hmm.
understanding our universe.
Right. So the plan today is to use this text to, well, really try and get our heads around what modern cosmology says about the size, the structure, maybe these potential edges of the
It
universe.
can definitely feel a bit mind-bending.
Oh, for sure. But this source, it gives us a good framework, I think.
It does, and it points to some maybe surprising ideas, like
Yeah.
why there probably isn't a physical wall at the end of space.
Huh. And how the expansion is different from just an explosion.
Yeah, exactly.
Right.
And the really key difference between the piece of the universe we can observe and, well, what the whole thing might be, plus some pretty wild ideas about what could be beyond.
Okay, let's dive into that first big one then. This idea of a spatial end. Like if you flew far enough in a spaceship, would you eventually hit something? The source says probably not.
That's the main takeaway from the source, yes.
Yeah.
It argues pretty strongly against thinking about a boundary in space like a wall you could reach.
And the reason for that is tied into how we think the universe works on the grandest scales, right?
Right. It leans heavily on something called the cosmological principle. The source explains this. It suggests that when you look at really large scales, the universe is pretty much the same everywhere,
Meaning.
meaning it's isotropic. It looks the same no matter which direction you look. And homogeneous space has the same general stuff, same properties everywhere.
Okay, so if it's basically the same stuff everywhere and looks the same every which way.
Then there can't really be a special spot, like a center.
Mm.
And if there's no center, then the idea of an edge, which is usually defined relative to a center, it doesn't really make sense in the same way.
Right. Like the source asks, if there was an edge, what's on the other side?
Exactly. The question itself kind of suggests it wouldn't be a real boundary. Because if you could cross it, then that beyond bit would just become part of a bigger universe,
Yeah,
you
that
know?
makes sense. Okay, but then what about expansion? Everything seems to be moving away from us and from everything else. Doesn't that imply some kind of starting point, some center it's all expanding from?
Uh, yeah. This is maybe the trickiest bit to visualize, and the source clarifies it well. The universe isn't expanding into some already existing void, like blowing up a balloon inside a room.
It's the space itself that's stretching.
Precisely. The source uses that classic analogy: imagine dots drawn on the surface of a balloon.
Yeah.
As you inflate it, the dots all move further apart from each other.
Okay.
But crucially, no single dot is the center of the surface. And there's no edge on the surface. From the perspective of any dot you pick, all the other dots seem to be moving away.
Got it. So galaxies get further apart not because they're flying through fixed space, but because the very fabric of space between them is expanding. Okay. So no spatial edge, just stretching space. But hang on. We always hear these huge numbers, billions of light years. Isn't that a limit?
That brings us to a really vital distinction the source makes. It's the difference between the observable universe and, well, the entire universe.
The observable bit just being how far we can see from here.
Exactly that. It's the region of space whose light has had enough time to reach us since the Big Bang happened.
And the source gives a figure for that.
It does. It mentions a radius of about 46.5 billion light years.
Yeah.
That's in every direction, centered on us because we're the observers.
46.5 billion light years. That number is just, it's hard to even process. But you're saying even that gigantic sphere isn't necessarily the edge of everything.
Definitely not, according to the source. It's very clear that this 46.5 billion light-year radius is a horizon of visibility. It's set by the speed of light and the age of the universe. It's not a physical barrier.
Ah, okay. So it's like looking out over the ocean, there's a horizon, but there's more ocean beyond it.
That's a good way to think about it. Beyond that observable sphere, the source says there's almost certainly more universe.
Hmm.
Loads more, probably. It's just that the light from those regions hasn't had time to travel across the expanding space to reach us yet.
So the part we can see is immense, but the whole shebang, the entire universe, could be way, way bigger, maybe even infinite.
Yes, the text explicitly states that. Based on our current understanding and measurements of cosmology, we just don't know the total size. It could genuinely be spatially infinite. That's a real possibility.
Okay, wow. So no physical edge in space. But you mentioned earlier the source talks about a different kind of boundary, a temporal one.
It does, yeah. If we're looking for some kind of definite end or limit, the source suggests it's more helpful to think in terms of time. This goes back to that cosmic horizon we were just talking about.
It's a limit on how far back in time we can look.
Exactly. Because light travels at a finite speed, and the universe has only existed for a finite amount of time, about 13.8 billion years.
So we can only see light from things that happened after the beginning, and only if that light has had time to get here.
Precisely. Light from very distant objects has been traveling for almost the entire age of the universe. But we can't receive light from before the universe began or from the very, very earliest moments right after the Big Bang when the universe was opaque to light.
So that earliest time, the Big Bang itself, acts like a boundary in time for our observations.
The source frames it that way, yes. It's the earliest point from which light can reach us. It effectively marks the edge of our observable past, our past light cone.
That's a really different way to think about an edge, not a place but a time, a limit on how far back we can see.
That's a powerful shift in perspective, isn't it?
Yeah.
It underlines that while space might be boundless, our view is limited by the universe's finite age and the speed of light. That gives us a temporal horizon.
Okay, let's loop back to space for a second then. If there's probably more universe beyond our observable bubble, what does the source suggest is out there? Just endless repeats of galaxies and stars.
Well, the source is quite careful here, emphasizing that this is inherently speculative because, we literally can't see it, right?
Right, by definition.
But the most straightforward and, frankly, most likely answer presented is basically more of the same,
More of the same.
meaning just more universe, structured much like the part we can see, filled with more galaxies, more clusters of galaxies, stars, planets, dark matter, dark energy, all obeying the same laws of physics we observe locally.
So the stuff beyond the horizon isn't weird and different necessarily. It's just too far away for its light to have reached us yet.
That's the simplest, most logical assumption based on the cosmological principle. Why assume things drastically change right beyond the point we happen to stop seeing?
Makes sense. But the source does mention some more exotic possibilities, doesn't it, when it talks about what might be beyond, things like the multiverse.
Oh, absolutely. It delves into that territory, but it puts up very big warning signs saying, this is highly theoretical speculation. It's fascinating stuff, active research, but it's not something we can currently test scientifically.
Okay, but what kinds of ideas does it touch on?
It mentions a few main concepts. One is the idea of bubble universes. This comes from theories like eternal inflation, where maybe our entire universe is just one bubble that inflated out of a larger, eternally inflating space-time sea, and maybe other bubbles form too, totally separate universes.
Wow, like cosmic bubble bath.
Sort of, yeah. Then there are ideas about parallel universes. These might exist alongside ours, maybe in extra dimensions we can't perceive, potentially operating under different physical laws or having different histories.
Okay. And the last one was brains. Sounds weird.
Right, brains, short for membranes. This idea often comes up in string theory. It suggests that our familiar three-dimensional universe might actually be confined to a surface, a brain, floating within a higher dimensional space, sometimes called a bulk.
And other brains could be other unibuses.
Potentially, yes. They might exist parallel to ours in this higher dimensional space. Again, highly speculative stuff.
So just to be clear, the most likely thing beyond our observable horizon is just more of our kind of universe, but these multiverse ideas are out there in theoretical physics, even if we can't prove them.
That's a perfect summary of how the source presents it. It gives you the probable, sensible extrapolation alongside the really mind-bending frontier theoretical physics ideas.
Gotcha. Okay, let's shift gears one last time. We started with that question. Does our world just float in nothing, or is it part of something bigger? Where do we fit in? Does the source address that? Does our world sit down in something?
It does. And the answer the source gives is basically, yes, absolutely, it's part of something much, much bigger. It lays out this amazing nested structure.
Okay, let's trace it outward. Starting from home, we're on Earth.
Right. Earth is obviously part of our solar system. The sun, the planets, asteroids, comets, all orbiting our star.
And our solar system isn't just out there on its own, right?
Not even close. The solar system is located within one of the spiral arms of a truly enormous structure, the Milky Way galaxy.
Our home galaxy.
Yes, and the source describes it as this vast disk of hundreds of billions of stars, plus gas, dust, and a whole lot of dark matter, all swirling around, bound by gravity, orbiting a supermassive black hole at the center.
Hundreds of billions of stars in just our galaxy, and the Milky Way isn't alone either.
Nope. The source explains the Milky Way is one of the larger members of a group of gravitationally bound galaxies called the Local Group. It includes Andromeda, Triangulum, and dozens of smaller dwarf galaxies.
Okay, so galaxies cluster together in groups. Does it get bigger?
Oh, yes. The local group itself is just one small part of a much larger collection of galaxy groups and clusters known as the Virgo supercluster.
A supercluster.
And even that isn't the end. The Virgo supercluster, the source explains, is itself just an outlying tendril of an even larger structure that astronomers have mapped out, called the Laniakea supercluster, which contains something like 100,000 galaxies.
Laniakea? That's immense. So these superclusters are like the biggest building blocks.
They're among the largest gravitationally coherent structures we know of, yes.
Right.
And the source points out that these superclusters, along with vast, mostly empty regions called voids, are arranged in a gigantic interconnected pattern throughout the observable universe. It looks kind of like a web or a sponge.
The cosmic web, I've heard that term.
That's the one. So you have filaments of galaxies and clusters surrounding these huge voids.
Okay, so Earth, solar system, Milky Way, local group, Virgo supercluster, Laniakea supercluster, all arranged in this cosmic web. So where does the cosmic web itself sit? Does that sit in something external?
And here's where the source brings it full circle. That entire web structure, all the superclusters, galaxies, stars, everything we see, it exists within the expanding space-time of the universe itself.
Ah, so the universe is the container.
By definition, yes. The source clarifies that the universe encompasses everything, all space, all time, all matter and energy. If you were to imagine something outside the universe, well, that something would just be considered part of a larger universe.
Because the universe is defined as the totality.
Precisely. It doesn't need an external place to exist in. It is the place.
So the answer to does our world sit down in something is yes. It sits within the solar system, which sits within the Milky Way, within the local group, the Virgo supercluster, Laniakea, the cosmic web, and the entire cosmic web sits within the universe itself.
That's the picture the source paints. We're not just adrift. We are deeply nested within layer upon layer of incredible cosmic structure, all unfolding within the universe as a whole.
Okay, let's try to sum up the key takeaways from this source material, the Boundless Cosmos. First, it seems the universe doesn't have a spatial edge like a wall. Instead, space itself is expanding.
Right. And second, we can see the observable universe is huge, about 46.5 billion light years in radius, but it's limited by the age of the universe and light speed. This gives us a cosmic horizon in time, not a physical boundary in space.
And third, the entire universe beyond what we observe could potentially be infinite. The most likely scenario is just more of the same out there, though multiverse ideas exist as highly theoretical possibilities.
Exactly. And finally, our place isn't just empty space. We're located within a complex, nested structure, Earth, in the solar system, in the Milky Way, local group, Virgo supercluster, Laniakea supercluster, the cosmic web.
And all of that structure resides within the universe itself, which is the totality of everything.
Too. It's quite a journey from feeling like a tiny speck to understanding our position within this vast interconnected system.
It really is. And thinking about that scale, the source describes not just the observable part, but the potential for an infinite universe beyond, maybe governed by the exact same physics we see here. It just makes you wonder, what does that sheer boundless possibility really mean for us, for our understanding of reality?
Or maybe flip it around and consider that other kind of edge. The source highlights not a spatial wall, but that boundary in time, looking back towards the Big Bang, that cosmic horizon. What does it fundamentally tell us about the nature of time itself, or about origins? That our view of the past is inherently limited like that, something to really chew on.